Origami is an art form where one sculpts a 2D or 3D figure by only folding a piece of paper. In fact, the word origami directly translates to of paper folding. However, the exact definition of origami is often debated. The one that will be used for this video is that origami must be made only out of folds, with no gluing or cuts. It can be made with any shape of paper, with the most commonly used shape being a square. Wait, why is it a square? Well, first off, a square is a simple shape to make, and has a lot of symmetry, which broadens the possibilities. But wait, doesn't a circle have more lines of symmetry than a square? Well, it is much easier to make precise folds with a square, therefore origami instructions are much easier to create and follow. Let's not forget that a square can make this. This is a bird base. Like all origami bases, it is the foundation of many things. While I could talk about the bird base more in depth, instead I'm going to focus on the origami subgroup to which it belongs, flat origami. But before we dive into that, we are going to need to know some vocabulary. A valley fold is a fold that goes down. A mountain fold is a fold that goes up. An active crease is a crease that is currently in use. An inactive crease is a crease that is not in use. Did you get that? Good. Flat origami is origami that is flat. Pretty straightforward. But what goes into flat origami? There is a set of characteristics that all flat origami has. If a model doesn't have all of these characteristics, it isn't flat origami. The characteristics are found in a model's crease pattern, which is what you see when the model's unfolded. We'll be using the bird base's crease pattern as an example. All active creases have color on them. Blue means it's a valley fold. Red means it's a mountain fold. The first rule is that the sections made by active creases can be two-colored, meaning the sections can be filled in two different colors, and a section will never touch another of its color. The second rule is that the number of valley folds and mountain folds at any active crease vertex must differ by 2. This can be seen here, with 3 mountain folds and 1 valley fold meeting at this vertex, as well as here, with 4 mountain folds and 2 valley folds. Another rule is that no layers can go through another. The final characteristic is the angles of any active crease vertex when numbered, has to have all of the odd-numbered angles add up to 180 degrees. Here, 1 is equal to 90 degrees, 3 is equal to 45 degrees, and 5 is equal to 45 degrees. Naturally, the even-numbered angles must add up to 180 degrees as well. 2 is 45 degrees, 4 is 90, and 6 is 45. However, they do not need to add up in the same way, as can be seen over here. Since flat origami has much simpler math behind it than 3D origami, professional origami artists calculate a flat base to create an abstract model of the project and then sculpt the flaps of the base into the final state. Another thing about flat origami is its ability to create tessellations. By arranging a pattern in a way it has all of the characteristics of flat origami, you can make a repeating version of it. Tessellations and flat origami, in general, have been used in engineering to compact and shrink things like airbags, star shades, stent grafts, other bodily supports, and even nanobots. In conclusion, origami is a fascinating study and learning tool with many real-world applications that you can practice and pursue as long as you have paper, interest, determination, and some optional things as well. Credit time.